Okay, welcome to this other chapter, and we are going to be looking at network address translation. Network address translation translates an IP address carried in the header of an IPv4 packet into another IP address. So basically, they're translating an IP address into another IP address. Generally, NAT is used to translate private addresses into public addresses so that devices can communicate across private and public networks. To alleviate the public IPv4 address shortage caused by the internet expansion, the NAT technology emerged as a temporary solution. There's IP version 6, which has a lot of IP addresses, which will be somehow sufficient for us. But because to date, so many of our connections are still relying and basing on IP version 4, and the IP version 4 addresses are being depleted. So these guys decided to come up with the NAT technology to help us see how we can reuse the private IP addresses to deal away with the shortage of IP addresses. So upon completion of this course, you'll be able to recognize NAT application scenarios, understand how NAT works, and also configure NAT on firewalls. So let us look at the NAT principle. Background is, I think in the early 1990s, relevant requests for comments, documents began raising the possibility of IP address exhaustion. And as more and more addresses were being requested, this driven part of the, the internet rapid growth due to TCP/IP based applications, they had to come up with a way of fixing this challenge because the IP addresses were getting depleted. So to address this challenge, they developed IP version 6 as a success of IP version 4. But in contrast to IP version 4, which is defined as an IP address of 32-bit value, IP version 6 has a size of 128 bits, which is quite enough when you go ahead and convert that to the number of usable addresses, which is quite enough. So, but this version 6 has a significant larger address space compared to IPv4, but however, it still also has a long way to go before completely replacing IP version 4. Due to the immature technologies and huge update costs associated with the IP version 6. So because IP version 6 will not completely replace IP version 4 immediately, certain workarounds were required so that they can extend the use of IP version 4. For example, they decided to come up with a classless interdomain routing and also the variable length mask, and also NAT, which we want to look at in this chapter. So private addresses used to implement address reuse and also increase on utilization of IP addresses. They came up with the private addresses, and we have a range of public addresses. We have 3 classes. We have which class and which class?
Class A, Class B, and Class C.
We have Class A, Class B, and Class C. Class A ranges from which address?
We have also D and E.
Yes, we also have those ones, but they're used for other things. Let us try and focus on A, B, and C.
A is from 1 to 1 to
10.0.0
to 1. Yeah, 10.0.0
to 10.255.255.255. Okay. Then B ranges from 172.16.0.0. And so many organizations use, or enterprises use this class B for their private addresses. 255.255. You forgive my handwriting. Class C starts from 192, and this is the most common one that most of you see, most of your computers, .0.0 to 192.168.255.255. These are the classes. But for any computer to be able to communicate and connect to the internet, what kind of IP address does it need? Does it need a private or a public IP address?
Public IP.
For
It's a
any
Public.
machine to communicate over the internet, they will need to have a public IP address. And these public IP addresses are only issued out by ISPs or the authorized agencies, right? Not every individual can as well as go and buy from an ISP and you purchase your own public IP address, but they are usually, they also buy and they are authorized or they're issued out by authorized agencies. For any computer to connect to the internet, you need to have a public IP address. So the private addresses can now be used on private networks. So I can have my private network and I have the same IP addresses. You can also have yours and you have the same IP address. You can also have you can have so many organizations, organization A, B, and C, and all these guys are using their private IP addresses, and it's okay. I can have 192.168.1. This guy can also have the same IP address, because at the end of the day, these guys' computers are communicating within his organizations, and there's no way they are going to affect. And if they need to connect and access the internet, then they will need to acquire or use a public IP address. So private addresses are used on private networks, whereas public addresses are used on public networks. And the main common public network is the internet. Okay. So to allow communications between private and public addresses, a network address translation must help us to translate our private IP addresses into the public address so that our computers can effectively communicate on the network. So the advantages of NAT, through using NAT, we can IP addresses can be reused. Okay, IP addresses can be reused, and the address translation is transparent to the users. So users do not know what is taking place. You're actually unaware that, oh, now my computer is connected to the internet, so my address is being translated for me to be able to access the Huawei page. No, you actually be unaware of the process that is taking behind. For you, just access a page and send your request and get requests, minus you being unaware of what's transpiring in the background. So users are completely unaware, or the address translation process is transparent to the users. Also, network address translation helps us to protect, to hide our internal topology or our internal network. So there's privacy protection, and it is available to our internal users, because if the hacker comes out there to see what you're doing online, they don't know, because even the address they are seeing, it has been translated. It's not actually the real address that you're using on your computer. So there's some kind of privacy protection which is available to the internal users. And load balancing among internal user servers is also available. But because of this privacy and protection, network monitoring is more difficult, because if you're monitoring and people have addresses that are being translated, sometimes also monitoring and tracking down where the packet is coming from sometimes becomes difficult. And some applications are restricted. They do not necessarily need you to translate their IP addresses. So the basic principle is that NAT translates the source and destination IP address in IP packet headers so that numerous private addresses can access the public network through a limited number of public addresses. Public addresses are more expensive to acquire, and you can have one public address and you use it to translate your internal IP addresses to access the internet. So you have your destination IP address, which is 123.3.2.3, and you have your source, which is here on your computer. So you go ahead and you want to send a packet, and the packet is now, they get it and say, oh, this is a destination, and now your source IP will be translated into 123.3.2, and now this is appearing to be as if it's a source IP address. So there's some kind of translation destination that is taking place and translates the address into public IP addresses. And now they go, and then you're able to access the FTP server, and then the FTP server goes ahead to send the packet again, and then it is translated again, and you see the destination IP address and source IP address is being translated and also decoded back to the original IP address. So that is what that is translation, and that's what happens when you're translating. So NAT translates the IP address in packet headers to other IP addresses so that the users on the internal network can access external networks. And every NAT device maintains an address translation table. And the IP address of the packet that passes through the NAT device require address translation, and to be translated against this table. NAT mechanism involves the following process: translate the IP address and port number of hosts into the external addresses and port numbers of the NAT device. And then after translating the external addresses and port numbers into the IP addresses and port numbers of internal hosts, this is what we are calling NAT. So what NAT does, it implements translation between our private plus port number and also our public addresses plus the port number. Usually the NAT devices, like you can see here, we're using a firewall to do our network address translation. They are located between internal and external networks, and the packet exchange between the internal hosts and external servers all pass through our NAT devices. And common NAT devices include routers and firewalls. We have these categories of network address translation, and it is divided into three subcategories: the address pool, outbound interface address mode, which some people call easy IP, and static mapping, which we're calling NAT server. So source NAT, we want to look at source NAT, which has two things in it: address pool mode and the outbound mode. So this enables multiple private network users to access the internet at the same time. We have the address pool mode here, and with the address pool mode, basically the IP addresses in the address pool are used to translate users' private addresses. So you have a pool of private addresses, and using public address, which are used to translate our private addresses for the users. This mode applies when you have when many private network users access the internet. There's also the outbound interface address mode, which we are calling the easy IP. And with outbound, basically the IP address of internal hosts are translated into the public IP address of the outbound interface on the public network. This mode applies when the public address is dynamically allocated. Like, let's say your ISP is the one who is giving you the IP address. This is when you use outbound interface. So we have also server mapping, and in server mapping we can have static mapping. This enables external users to access servers on a private network. You're going to do some kind of static mapping, and you're going to map like one-to-one because you don't want your server not to be accessed. So in static mapping or NAT server, which some people call NAT server, it maps one private IP address to one public address. And this mode applies when public network users access servers on the private network. So let us look at source NAT and see the things that are inside source NAT. We said it has address pool mode. I want you to look at how address pool mode does the network address translation. So the address pool mode without port translation, there are two modes. There's one with port translation and there's one without port translation. So let us look at the one without port translation. NAT translates the source IP address, that is the internal or the private addresses in the IP packet header into a public address. This enables, if you have numerous hosts on your network, to connect to the internet through the limited public IP addresses and effectively hide the host IP addresses. On the LAN, they help you hide and help you protect you from internal people. They are unable to know your internal structure. So the address pool mode without port translation is implemented using NAT pool that contains multiple, here the keyword, that contains multiple public IP addresses. So if all addresses in the pool are allocated, then NAT cannot be performed for the remaining hosts, and therefore the packets could be discarded and the user will not be able to access the internet. So if you have multiple address, public address, you have public address 1, you have public address 2, you have public address 3, you can use this computer 1 or computer B or computer C. They can be able to translate their IP addresses to these guys and they are able to access the internet. But when the fourth computer here tries to access the internet, he will not be able to access the internet because there's no public IP address available for him to use, and therefore his packets will be discarded. What will happen to him? He will have to wait until these guys release the translation from one of these packets, and then he can use any of these for him or for her to be able to communicate. So this is port address pool without translation. You have your source IP address and destination IP address. When it comes to translating, it is translated into the public IP address, appears to be like it's a source. It is sent out to the destination, and when also it's coming back, the destination will be this guy, and then the source will be the source for this guy of our server, and then after translating it, it will go all the way to the private IP address and communication will be successful. So let us look at address pool mode with port translation. So address pool mode with port translation, here we have our source address. As you can see, there's an important factor here which is being added there, and there's also port. So port, it will also translate the address, at the same time it will also translate the port. Those are two things which are being translated, the address and the port, and then communication is successful. So the address pool with port translation is implemented using a NAT address pool that contains either one or more public addresses. The beauty with this, you can even use one public IP address for you to be able to communicate and have your devices communicate to the public network. So we use addresses and port numbers to translate our private addresses that share, which can share these public IP addresses. Can be either shared one or they can even share more. So because of address and port numbers that are being both translated, multiple users on private network can share one public address to access the internet. And the firewall can distinguish users based on port numbers so that numerous users can access the internet at the same time. This technology uses layer 4 information. Technology uses layer 4 information to extend the layer 3 addressing, and theoretically you can have about 65,535 private addresses using one same public IP address to access the internet. So compared with one-to-one or multi-to-multi address translation, this mode greatly improves address utilization, and addresses pool mode with port translation is commonly used. People usually use this kind of address translation because you can use one IP address, like you see in this illustration. You are using different addresses mapped to the same IP address but different port numbers to implement many to one address translation. We have one address, this guy that you can see, but we are just now translating our port numbers to access the internet. So these private IP addresses are using this NAT pull mode 2 with port translation to access the internet, as you can see in the illustration. So we'll want to look at easy IP, or what we're calling the outbound interface address mode. Here we said you use it when usually you have a dynamic, your public IP is dynamically assigned to you. So with this outbound interface mode, you have your source address and you have your destination address, and it is translated. But when it's being translated, it uses the interface outbound. It uses the outbound interface IP address to translate the IP addresses, just like you can see in the illustration. So here, Easy IP translates private IP addresses into public addresses of the outbound interface without the need of configuring a NAT address pool. And addresses and port numbers are both translated so that private addresses share public addresses of outbound interfaces, just like you see in the illustration. So we want to look at the NAT ALG, what we are calling the NAT application level gateway. It is a translation proxy that is used for certain application protocols and can translate the address and port number carried in the application layer data. So previously, NAT was looking at the TCP header and the IP header, but can't we also use the application header to also do some kind of port translation? So this is what it looks at, the NAT ALG. So the NAT ALG application FTP mode, you have your implementation principle. You look at the source IP address, which is being translated into the public IP address. You set up a control connection between the host and the FTP server, and then the host will send you a port packet, and then ALG processing will start, and the payload of the port packet now has been translated, and after it has been translated, the FTP server will then now initiate a data connection to the host, and then the host will get the information that a data connection has been initiated. Then after that period, transmission of data over an established connection can take place. So use the ALG, which also looks at the application packet header. So we want to look at server mapping. We looked at server mapping in the previous chapter, and NAT server, internal server. We have a NAT server function, and it uses a public address to represent the private address of an internal server. So on the firewall, a public address is configured to represent the server's private address, and external users can access the server through public IP addresses. So on your server, when you're connecting, you're configuring it, you configure it with your real IP address. But you go ahead and you configure a public address on the firewall, and the firewall, if people want to access your server, they have to access the firewall, then which will actually have to translate into your private IP address to access your server. And this helps you to protect your server from people getting to know its private topology, and also from getting to know its private address, and also limiting the possible hacking scenarios. This is how you can generate the server map table, or you can type in these tools for you to be able to see an entry. So after the NAT server is configured, the device automatically generates server map entries that map either between our private and public IP address. So you go into your firewall. When you open your firewall, it looks like this, and you're in system view. NAT server, you type in the code, you specify the protocol, you say that I'm going to use TCP, and it's going to be connecting to the internet, and then you go and you specify the public IP address, you go ahead and specify the private IP address. So NAT server map 2, this is also when you're going to configure, and you're going to use the word no reverse And if no reverse is specified, the device generates only the forward or server map entries. It does not going to record the reverse server map entries. And the application scenarios, what we use NAT, and we use NAT application scenarios. We're going to look at source NAT and also the NAT server application. So if you want to access your file server, you have to use the NAT server or the static NAT for you to be able to access your server. Source NAT, you can use it, in your local area network so that people can translate and be able to access the internet. How to configure the source NAT on the firewall, we also look at that when you have set up the firewall. It will make a lot of sense and it will be easier as just looking at these things here that do not necessarily make sense. But basically, that's how it will be. That's how we will be able to configure it. So we want to look at twice NAT and the application scenarios. Twice NAT, basically, you are using NAT server plus the source NAT. And also you can use the intrazone NAT. So the intrazone twice NAT, to simplify the configuration of the route from a server to a public network, you can configure the source NAT based on the NAT server function. So you have your internal server here, it has its real address here, and you have your private address there. So you can configure yours, and you have your source NAT, and the source NAT will translate it into a private NAT, which is also translated, and then the file will go ahead and also translate to a public IP address. So we have like twice kind of translation, and this will also help you to achieve better security. So when the packet comes through, it will have to be translated and translated into the first first public private address, and then later on translated to the real address. So in the firewall, in twice NAT, the firewall translates the destination address of the user's packet requests into the private address of the FTP server, and it also translates the source address into the public address of the user. The file will translate the source address of the response packet from the FTP server into the public address, and it also translates the destination address into the basically they're just showing you the process. So when it comes, it's translated it into that of the firewall, and after translation into that of the private address, and then to that of the real server. Quiz: which of the following areas of why NAT emerged? Who was attentive? Which of the following are the reasons why NAT emerged? Which of the following? Yes, please.
A and B.
A, B.
A and
B. A and B. Okay. Very well. Very well. So that brings us to the end of this. And I want to communicate and say that I'm going to put up together videos that are going to show you how you will download some files, how you'll be able to install them, and how you will run them, and then